Hi students, today I am going to explain the laws of thermodynamics. So we know there are three laws, first law, second law and third law of thermodynamics, and even there is zeroth law of thermodynamics. So we can say there are four laws of thermodynamics. So first and second law was proposed by Rudolf Clausius and William Thomson in 1860. So what is the first law? So according to the first law, total energy of the system is constant. So energy will be same anywhere, the energy will be same, it will not be changed. Means the energy, we cannot create the energy or we cannot destroy the energy, only we can convert it from one form to another. So the energy can be neither created nor destroyed, but we can convert it from one form to another. So it is written in equation form. So energy, so delta U is the internal energy, that is equal to heat plus work done. So some work is done, it is some part is used, some energy is used for work and other is used as heat, but the total energy will be same, it will be just converted into heat and the other mechanical energy. So the energy will be remain constant. So for example, plants, so it will take sunlight during photosynthesis. This sunlight energy, it will not go anywhere, it will be constant and it will be converted into chemical energy by photosynthesis process. This is one of the example. Then second law, so every energy transfer that takes place will increase the entropy of the universe and reduce the amount of usable energy available to do work. So we told we can convert the energy from one form to another in the first law. So like when the energy is transferred from one form to another, so what happens, some amount of energy will be wasted. So in this process the entropy will be increased. What is entropy? So entropy is nothing but a degree of disorder. So disorderness will be increased. So for every energy transfers, whenever the energy is transferred, so the disorderness in the system will be increased. In the universe, the entropy will be increased and the amount of usable energy will be decreased, reduced. Means the amount of usable energy is decreased, means so much of energy is wasted. So the amount of energy will be wasted. So this is in the equation form. So delta S is equal to Q by T. Delta S is nothing but S is entropy. So degree of disorderness depends is equal to heat by absolute temperature. So always the delta S, entropy of the universe, will be always greater than 0. Means it will be increasing in the universe. So whenever the energy transferred from one form to another, some energy will be wasted. So useful energy will be reduced and the disorderness will be increasing. So entropy will be increasing. So that is second law. And the next law is third law. Who proposed this? Walter Nernst. So the entropy of a perfect crystal, when we take a crystal, perfect crystal, is 0. Means no disorderness is there in that crystal. It is a perfect crystal. So when the temperature of the crystal is equal to absolute 0. So when the temperature is 0, absolute 0, then there will be no entropy for the perfect crystal. Means there will be no any disorder. So it will be a perfect. So when the temperature increases from absolute 0, then the particles will be moving fastly and the energy will be changing and the entropy will be changed. So entropy will be increased. That is what third law. Or we can also say it is impossible in a finite number of steps to reduce the entropy of a system to its T is equal to 0. So value. So it is impossible in a finite number of steps, a countable number of steps, to reduce the entropy. So we cannot reduce the entropy. Degree of disorderness we cannot reduce to its T is equal to 0 when the absolute temperature is 0. So 0 value, then we cannot decrease the entropy of a system in a finite number of steps. Means it is possible in a infinite number of steps. So that is third law. So one more law is there, I told, that is zeroth law. Who proposed this? Ralph Fowler. So what he told, if two systems are each in thermal equilibrium with a third system, when three systems are there, so two systems are in thermal equilibrium, they are in same temperature equally, then the third system will also be equal with each other. So and they are also in equilibrium with each other. So if two systems are each in thermal equilibrium with a third system, so these two are in thermal equilibrium with the third system, then all the three will be equilibrium to each other. This is zeroth law. Thank you.